Hello everyone, this is the video lecture for Calculus 3, section 15.2, more double integrals. So this section basically advances the concept a little bit by giving you dependent functions on your integrals. It's kind of weird. Let me just show you. So 15.2.001. Very easy here. Here we go. Going from 1 to 5. Now we're going 0 to x. And that is the main difference between this section and the last one. Notice that we have this function, essentially, that is defining what my integral will be here. So this is still in terms of y, okay? So we're going to integrate in terms of y, but instead of just putting numbers down, we're putting down letters. And then we would integrate those letters. These letters here must be in terms of ones that are subsequent. So you can't use a y here if you're going to integrate in terms of y. That just doesn't make sense. But really, they don't set you up for failure or anything like this. If you're wanting to know like what this region would look like, you're going from 0, y equals 0. These are y's, right? Y equals 0, y equals x. It's a 45-degree line. And we're going from 1 to 5. So 1 to 5, let's say. And so it's just this region right there. Okay, of course that's not the, if we're not looking for the area here, because notice that we actually have a z value. Therefore, we're looking for the volume. But we don't have to go that far. We're just saying, hey, what's a double integral? So 1 to 5, we're going to integrate this thing here in terms of y. So we get 6xy minus, again, y squared over 2. The 2's cancel, make a y squared only, 0 to x. Whenever you plug in the x, here and here, we get 6x squared minus x squared. The 0 is going to cancel everything, so no need of that. And so when you're really looking here, 6 minus 1 is 5. Okay. When I'm integrating this in terms of x now, we would get the cubed over 3 from 1 to 5. Plug in the 5, plug in the 1, both of which are important here to you. I think you get a, hold on here, see 5 times, and then you get 5 cubed, 5, 25, 125 over 3 minus 1/3, blah, 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 math, and use the calculator, this is what you get. So there you go. Let me pause the recording for just a second. Moving on. So, we got now 15.2.004. It says double integral 0 to pi over 2, 0 to x of x sine of y dy dx. Okay, again, we're going to be doing the y first, and then we're going to plug in that x into y. Here in a second. So if I'm integrating in terms of y, notice the sign, when you integrate it, will go to a negative cosine. We're so familiar with derivatives that often we don't think about going backwards for that stuff. So it'll go to a negative cosine, 0 to x. Again, be careful here. I believe I messed up on this problem because I was not careful. Yes, you plug in the x and everything's fine. Well, you also have to plug in a 0 here because cosine of 0 is a 1, so it actually doesn't just cancel out or something. Okay, so we have this, and then, of course, when I plug in the 0, so now minus a negative, so minus a negative makes a positive, cosine of 0 is a 1, leaving just a plain old x. Okay, so if you tried to do this on your TI-83 or something like that, you're going to get a crazy decimal because the answers are actually kind of weird. So let's go through this integral together. The main thing that's going to be strange is this guy right here. Like, what's the integral of that? Well, you go to a formula book. So in the formula book, I'm sure we got something. U cosine u. There we go, right there. Notice that mine is negative in the front, so I'll just have a negative and then a negative. So negative cosine, and then a negative u sine u. Okay, so let's try that. So now I'm integrating negative, and then I gotta remember here, cosine u, which is now x, and then a negative x sine x, essentially. So just for this piece right there, what's your integral of this one is x squared over 2. Cool. And now the from 0 to pi over 2. Again, be careful that 0 might still actually give you something, okay? So plug it into pi over 2. I got a negative 0. Cosine of pi over 2 is 0. Sine of pi over 2 is 1, so then I just get that negative pi over 2 business there. And here, it's kind of strange because I got pi squared, and then I got 3 2's in the bottom. 2 times 2 times 2 is actually 8. Okay, so all this minus, and then when I plug in a 0 into everything, cosine of 0 is actually a 1. So negative, and then a 1. Sine of 0 is 0, x there is 0, so it doesn't matter. So like, I guess you can put some zeros if you want to. This guy will make a positive 1 in the end, so positive 1 minus pi over 2, but then plus pi squared over 8. And that is your final answer. Next question, 15-2011. I got double integral over a d. That d stands for domain. I don't really know what the difference between a domain and a range is, or a domain and a region, whatever I was having there. You saw an R there versus a D. I don't really know. It doesn't really matter that much. DA. I think the D's are normally for 3 dimensions. R's are for 2 dimensions, so I don't know why they're doing that here. Anyways, I guess they could just use any kind of letter they want. I mean, it's just a letter. Okay. Notice that this one here has got that square root x kind of business there. And that's why we are seeing this in 15.2. So let's go ahead and just write it out. 0 to 6, 0 to the square root x of y over x squared plus 1 dy dx. I'm going to be integrating the y first. Notice right here this y. Wouldn't that be y squared over 2 whenever you start integrating it? From 0 to square root x. When you toss that guy in, square root of a square cancels one another to make a regular x. Then at half, I guess you could just pull it to the front. I'm going to pull it to the front. So regular x there, x squared plus 1 right there, dx. Cool. So what do we do now is use substitution. X squared plus 1, du is 2x, dx, and then dx is du over 2x. Taking these two guys here, we got 1/2 integral of essentially x over u, du over 2x, and the x's cancel like we know they should. 2 comes to the front to make a 1/4 integral of 1 over u du. Don't mistaken, this is a 4, and that's a u. So 1/4, your integral right there of this guy would be an ln of u. And when we replace my u with x squared plus 1, again always positive, from 0 to 6. Plugging in the 6, you get 37. And then plug in the 0, you get ln of 1, which is a 0, so you don't really need that. There we go. Next one, 15-2023. Double integral, 7x cosine y dA. And then they say that it's bounded, this region here is bounded by y equals 0, y equals x squared, and x equals 1. So I want to draw this in 2 dimensions to kind of show you what it looks like. So y equals 0 is right here. So that's y equals 0. The axes, the x-axis. X equals 1 is basically right here. It's the vertical line at 1. And then I got x squared, which is a parabola. And so you can see the region's going to be this guy right here, that small little triangle looking thingy there. So that's my region. Okay, so I want to set my integral up here correctly. dy dx almost always preferable. I want my y values here, my x is there. But notice I want to do top and bottom. If you ever remember how this works, this down here, I know that we say bottom and top, maybe because they're actually on the top and the bottom of the integral here. But when we're taking two different graphs, we got a top and a bottom between two different x values. Okay, so from this to that, essentially. So what's on the bottom is 0 for my y. This is on the bottom, while this guy's on the top. Okay. This over here is left to right. So if you notice where my region is, it's going to go from 0 to essentially 1. Now, they didn't give you those 0, but you can see from the graph how that would work. Or I guess you could just plug in y equals 0. So therefore 0 equals x squared. Therefore x equals 0. Phew. All right, so integrating this in terms of y. Again, that's a cosine. Integrating goes to a sine, actually. When you plug in a 0 for sine of 0 is 0, so that's not a big deal. Not worried about that. But we would get sine of x squared. To make this thing work, use substitution for the inside. 2x dx. Dx equals du over 2x. You're using these two guys here. So then we got 7x sine of u, and then du over 2x. X's cancel. The 7 halves can come out to the front. So we got just sine of u du. Your integral of that is a negative cosine. Again, you're integrating. Keep that in mind. Plug back in the u, and we're going from 0 to 1. The 0 actually is meaningful, so be careful here. You get cosine of 1 minus, and then when you plug in a 0, cosine of 0 is a 1. So it's kind of a strange answer, but to get like cosine of 1, degree? No, that's radians, so cosine of 1 radian, which is, I think, 57 degrees or something like that. So it doesn't really mean much to us, but it is a numeric at least. And it is correct. So, next problem, 15.2.0.31. So they want the volume under this plane, 7x plus 2y minus z equals 0, and they want it above y equals x squared, and then x equals y squared. Well, notice right here that essentially I'm going to say z equals 0. I don't know if they even said that in particular. They probably did. But I'm going to go ahead and tell you z equals 0. It's somewhere in the problem, I'm sure. I don't think they would assume so much of that. Not that I didn't write it down, but it's probably saying something like first octant or something like that. I'm not really sure. So what does that look like? In 2D land, we got a parabola and we got a square root, and they want this region here. And you can notice that if we take the z, move it to the other side, we get our double integral z to find the volume. 7x plus 2y dy dx. So how do we find this in terms of x's and y's? Notice what's on the top and what's on the bottom. So for my y's, what's on the top is actually a square root. Now, you might not have noticed that. Let me just do that right quick. Y equals plus or minus square root of x. Of course, we're only talking the positive because we're colliding with this parabola right here. I mean, there's still more of each, but they're not talking to one another, so it doesn't really matter so much. So the top is actually going to be the square root, while the bottom is x squared. Not very intuitive to see that. Okay, I actually did this problem incorrectly by swapping those. I had to go back and, well, change everything. My region here for x's is going from 0 to what? Where am I colliding? At 1, actually. So 0 to 1. Again, you can solve for stuff to find that. kind of assuming that you've seen that kind of thing before. So first integral here, in terms of y, 7xy plus, again, 2 will cancel with the divide by 2 when you square it, from x squared to square root x. Now this is a strange coincidence whenever I'm plugging in square roots and squares. So it's going to be kind of weird. Square root x there. Square and square root cancel, leaving just a plain old x. So all this stuff minus, and now I'm going to plug in the x squared. So it's weird because you get now a cube, and squared squared will get you a 4th power. All this, to be technical, dx. Really, none of these terms actually combines with one another. So we're just going to go ahead and integrate it. I think the best thing that you can do right here, though, is see this as 7x to the 3 halves. That's going to be a helpful hint whenever you're integrating. So now it's going to be 7, and now it's going to be x to the 5 halves over 5 halves, x squared over 2. Both of these are going to be negative. 7x to the 4th over 4, and then 7x to the 5th over 5, from 0 to 1. Well, 0 cancels everything. 1 is going to make it all the x's essentially go away to make it easier. So 7 times 2/5 plus a half minus 7/4 minus 1/5. Definitely calculator at this point. 27 over 20. Makes it much easier to use a calculator at some point. Keep cruising. 15.2.033. So they want, I think it's the volume under z equals 7xy. And they say above the triangle created with these points. 1, 1, 4, 1, 1, 2. So first off, what does that triangle even look like? Well, we got 1, 1, 2, 3, 4, and then we got 1, 2. It's this triangle right here. Okay. So they want this region essentially, but then this is my, actually it's not a plane, it's just going to be a surface above it, and find the volume of that. That's fine and dandy, no problem there. So how do we make this thing work? Well, when I do my double integral of 7xy dy dx, I need functions here in terms of x, and then I need some numbers here. So I need to like fill in all this stuff like I have been. What I'm going to do is see this as 2 lines here. Sorry, my drawings are not perfect. That's a line, and this is a line. I know it's not perfect. I'm sorry for my not straightness. It's just this drawing tablet. So I want these 2 lines in terms of y. Well, this one's going to be super easy here. That's y equals 1 for the flatness. But what's on the top? I'm going to tell you it's mx plus b. Now, I don't know what those are yet, but I'm going to use these 2 points here, from right there and from right there, to find my slope. 2 minus 1, 1 minus 4, 1 over negative 3. And so that's going to be my slope. And then y minus 1 equals negative 1/3 x minus 4. Move this, distribute, move this guy over. I'll just give it to you. It's negative 1/3 x plus 7/3. So that's my line for the top. This is my bottom. And so here we go, filling it all in now. I got my bottom is a 1, while my top is negative 1/3 x plus 7/3. 7xy dy dx. Now, what is my x going to? Notice that I go from 1 until 4. 1 to 4. I'm going to tell you this one's going to get really crazy here in a second. So let's do my integral here, 1 to 4. So then integral this y's. My y is going to go to y squared over 2 from 1 to, well, this line right here. Dx. You need to toss this whole thing in for the y's. 7 halves x. And then this is where it gets kind of weird. It's going to be Negative 1/3 x plus 7/3. Cool. Minus, do it all over again for the 1. Oh, wait. Wasn't that y squared? Squared. Whoa. Okay. Let me just tell you, if you want to start foiling this thing out, go ahead. I think it's nuts. It's a crazy problem. Yep, it's pretty crazy. So I'm going to recommend calculator, and it actually does work. I got the correct answer immediately. Math to frac, of course, but don't hesitate on something if it's especially the homework. And it's just, look at that thing. You're going to FOIL out those fractions and then combine like terms. I'll see you in about an hour, but other than that, okay, because we got better things to do. So the next one. This one's a three-dimensional problem. Volume, we're bounded by the cylinder. X squared plus y squared is equal to 16. And then also y equals 2z. X equals 0. Z equals 0. And then they want to keep it in the first octant. Okay, what is going on? Well, first off, I want to redo these right here to make them simpler for us. What if it was z equals 1/2 y? And what if over here this was y equals the square root of 16 minus x squared? Again, first octant means I could just have it positive and it's not a big deal there. Cool, so what is this all going to combine and look like and stuff like that? Well, in 3 dimensions, and I'm going to try very hard to make it look good for you, but if you're kind of getting lost in it, you can forget this and skip ahead. So, a cylinder with a radius of 4. So we got the cylinder like this. Again, not the best. I can't draw it super great, but that's a cylinder at radius 4. Let's change my color for a second. And so we're keeping in the first octant. So we're looking only right here at this quarter circle thing right there, okay? It's important to see. As far as height-wise, though, we're needing to go as high as we need to go. So this guy right here, z equals 1/2 y. It's kind of strange because you're looking about this YZ plane and it looks kind of like a line. So that line is going out as a plane like this. Okay, now that's technically kind of like this, okay? It's going up at a slope out from this origin, from this x-axis here. So that's going to be the volume is going to be this kind of circular part up here connecting with this. It's kind of like a piece of cheese probably from a cheese wheel. But looking at it from the side, so this is, let me redraw that. This is my XY plane, and this is Z. So what you're seeing is that we have this cylinder here, and then I'm cutting into it like this, and I'm wanting that triangle little area volume there. I want that volume, okay? So it's kind of like a cheese wheel. I'm cutting part of it out in a way. So how do we find this volume at all? Well, keep in mind that this, I'm going to use a different color, my region two-dimensional wise on the XY plane is right here. And so if you were to look at that XY, it's actually, that's supposed to be a Y right there. It looks kind of like just a quarter circle. Again, they said first octant, so it makes it easy, to a radius of 4. Okay, so this is going to be what my double integral is going to be focused on, but then I need to find out how to get that volume and stuff like that. Well, I think it's just going to be this guy. And so let me show you what I'm going to do. My volume is equal to, 1/2 y dy dx. And so my top there, if you can notice, this is the top. My bottom is down here. Bottom. So my bottom is 0. My top is actually the square root of 16 minus x squared. And where is x going from 0 to 4? Okay. Back to black. So let's try to find this one. I'm going to integrate the first part in terms of y. y squared over 2, of course, from 0 to this big square rooty thing, dx. When you toss that in, 0, of course, cancels. I can put a 1/4 in the front. When you square a square root, you'll get back to the original. So that's actually not too bad to integrate now. 16x, x cubed over 3 from 0 to 4. The 0 will cancel everything, so the 4 is going to be important to you. 16 times 4 minus 4 cubed over 3. Eventually you just do calculator. That's 64 basically for those guys. But then when you cut it with the 4 there, 32 over 3. And, well, there you go. Okay. Now, I was going to do another problem, and it's a really cool problem, but it's no longer on the homework because I removed it. Its randomizations were not very well done. So I'm actually going to skip it. I know that I probably just shouldn't have said anything on the recording. It was a cool problem, but sadly sometimes I just, let me just tell you, I got an answer with a 2667, and their answer was 1667. Now, there's multiple times of different things, and one of the randomizations that was not working. So if you ever encounter randomizations that are just not working or something, you tell me. I mean, nothing's ever perfect. And so as I'm going through the homework, I discover things that, are not right, and I have to send it in or whatever. Same with you. If you find something, tell me. So I'm going to just skip over that, but it's just a point that as you're working through, I mean, surely there's been a lot of people working on it, but sometimes there could be issues not with just the whole problem, but a single randomization in that problem even. So contact me, of course, if you got questions. I'm here to look it over and stuff. Okay, this problem here, it is asking to reverse the order of integration in order for us to be able to complete this. So let's get this straight. This is 5e to the x squared. Okay, x squared is all in the power. And they say integrate this. Well, let me tell you that this is impossible unless you, again, they say reverse order to integrate, something like that. Some kind of directions like that. We need to look at this side and draw like a picture, understand what it looks like. So again, remember, this is x equals in this particular case, x equals. See how it's x first? Okay, so these are the tie-ins, and these are y equals. If you want it to be more formal, you can actually just list them out on the side as just a whole bunch of like equations and start drawing these. Draw these guys and see what it looks like. Well, notice that drawing, all of these are fine except for this one here. You might want to swap them. So divide by the 3 to make it 1/3 x. It's a little bit easier to draw. So let's draw that one first. 1/3 x. There we go. Y equals 0. Y equals 3. I don't know. And then x equals 9. If you were to put a 3 in right here, wouldn't you get 3 times 3 makes a 9? So that's probably my 9 right there. And then, well, I think that's it. So let's just be careful about which top or bottom we're talking about here, okay? So I have my line, and I had y equals 0. And then they said x equals 9. And they kind of tied this thing in here, but notice the one part that they didn't close off here. They didn't close this part off. That one's open. Okay, so I'm putting that red to show you that it's not actually bounded. These really thick black lines are bounded, but not here. You can pass right on through that. Therefore, what is truly bounded here is this inside here, okay? Just watch it. I know it's easier with like multiple colors, and maybe I should have done that. So notice that we're going to have a top and we're going to have a bottom when I start integrating this thing. So for my y's now, I'm going to say my bottom is 0, my top is 1/3 x. My x's are going from 0 to 9. Again, the same inside. This thing never changed. Don't change anything here. Hold on. But now it's dy dx. Notice that I just swapped these. Okay. But I had to change, if you go back to the original, I had to change a lot of stuff. Not just swap those and walk away. It would be way wrong. So you have to go and actually draw it out to see what's going on. But you do this because, look, how many y's do you have? None. So basically you just throw a y in there. Oops. From 0 to this 1/3 x business. Toss it in. And so what you actually get is a 5/3, which I'll put in the front, at x, e to the x squared dx. You could not have integrated e to the x squared by itself. You needed this x here for the u substitution. du is equal to 2x dx. dx is du over 2x. Again, using these two guys. 5/3 still in the front. X e to the u, du over 2x. Cancel, cancel, move the 2 out. So now you got a 5/6 integral e to the u du, which turns out to be e to the u. Again, no plus c's or anything here, okay? Because I'm plugging back in my u, it's x squared, from 0 to 9. Actually, the 0 gets you a real number. So watch out here, it's actually important. E to the 9 squared, and then minus e to the 0. And so my answer is kind of funny looking here, but it's a good answer. E to the 81, 9 times 9 is 81, minus 1, essentially. There we go. One last problem. So in 15.1, they talked about average value on one of the problems near the end. I skipped it in that lecture. I'm doing it here because eventually I might as well do an average value because I want to show you the formula. So the average value is volume divided by area. Volume divided by area. It's kind of funny how that works. So like if you had like xyz divided by xy, well then those guys cancel, leaves a z, which is a y value, or it's not y value, it's a height value, I guess you can say. Anyways, so f of xy is equal to 5x sine y, and they give me these curves to bound it. Y equals 0, y equals x squared, x equals 1. Before I keep going, what is that even going to look like? Well, I got a parabola. Y equals 0 is this line down here. And the x equals 1 is about right there. So they're talking this, it's not a triangle, but it kind of looks like a slopey triangle kind of area. Okay, cool. So my average value should then be double integral of this region here. So y values top and bottom, 0 to the x squared, and then 0 to 1 of 5x sine of y dy dx divided by the area. How do you find the area of this? Well, you do the same thing that you did earlier with a 1. Like, what's your height? Well, you don't want to say 0, because then everything's just 0, right? So you're saying it's a uniform height of 1. Basically, it's kind of like xy times z. Well, then what if I just put a 1 there? Well, x times y is now the area of a box, like the area of a rectangle. So x and y. So you're reducing it down from volume to area by putting just a 1 in there. Okay, so we're kind of doing two integrals at once here. If you want to just do them separately on the side, that's okay. It's not too bad. So what's the integral of a sine? It's going to be a negative cosine. Hold on. Negative cosine from 0 to x squared dx. And then down here, when you're integrating, well, you just get a y from 0 to x squared dx. And so, plugging in this guy, remember plugging in a 0 for cosine is important. And I think that's where I messed up on this problem one time. So watch out. When you plug in a 0 here, you get a 1. Two negatives will make a positive dx. And that's going to be, what was it, 0 to 1? Yeah. On the bottom, it's much easier. Just x squared. Okay. Now I'm going to integrate this thing. Notice it's integral of... Whoa, I forgot. There's an x right there. So you're going to do u substitution for the top there. X squared, we already did all this, 2x, and etc. So you divide by 2, essentially. So negative 5 halves, and then you're integrating here. So integral of negative cosine is going to go to negative sine of x squared now. Actually, I put 2 negatives there. See how I already have the negative in the outside there? So I'm just going to leave that there and make it a sign here. That's going to be fine. Okay, that's better. This guy integral is much easier. X squared over 2 essentially, so 5 halves. Just coincidence that it happens again. X squared. Again from 0 to 1. In the bottom, we get x cubed over 3 from 0 to 1. The 0 is going to cancel everything out for sure. So you don't even need it. I would say just plug in the 1s everywhere. So when you plug in a 1 here, you get, well, sine of 1. Here you're going to just get the 5 halves. And down here you're just going to get a 1/3. So how it works in the end is you... I'm going to toss this 1/3 up and flip it. So it's now going to be negative 15 over 2. Actually, I'm going to factor that 5 halves out as well. Leaving behind... If you... Hold on. If I factor out... This is a negative here. So if I'm factoring out a negative 5 halves, here it's going to change the sign. Not the SIN sign, but a SIGN sign to a negative 1. Yep, that's the answer. So, kind of weird. I know you could probably have put something else into WebAssign and it'll accept it. Doesn't have to be super simplified anyways. All right, we're done with that recording. Thank you very much. Have a great day.